right, guys, let me try to catch up to you. Rah. Right. So what was the highest data point? 45. And the lowest? 17. 17. And when you divide that by 6, you get 4.6, blah, blah. So you round it up. You always round up if it's not already a whole number. Don't forget, if it comes out to a whole number, that's when you're always going to have to do that weird thing at the end where you have to increase the last number by 1 so you can capture that last data point. If it comes out exactly right, there's always going to be one data point left out at the end. So you just increase the last one by 1 so you can suck it in. We did that on the very first one we did together. You guys remember that? Some of you are shaking your heads, so I'm going to go with that. All right, so our class width is 5. I'm going to do it I think more of you are doing it my way, but I'm going to just do it the book way, just because that's the weirder way. So in case you're doing it that way, I want you to be sure what's going on. So pretty much I almost always start at 17 unless there's some advantage to otherwise. You could have started at 15 since our width is 5. Does that make sense? But I don't think anybody did. All right, good. Okay. I want to look the same for everyone. So if I start at 17, this first class would go from 17 to, because what would have to be here? So what's got to be there? 21. Otherwise, where would 22 go? In 2 places? Can you guys close the doors on the outside? Thanks, guys. Yes, sir.
Is this the way it's in the book?
Yeah, this is the book way.
Okay.
If you do it, let me show you on the side here. If you did it the way I used to do it, I was taught, this would be 17 less than or equal to x less than 22. And so forth, right? And that way is, again, that way is better, just to be blunt about it. If you don't do it that way, you're not going to be on any kind of a bad list with me. I don't care. You know, whichever way makes more sense. And again, it kind of sucks. As a student, I think I'd feel more comfortable with the textbook because then I always have that to kind of go back to also. But the other way is just so much better for so many reasons. But I'm going to do this one this way, just in case. If you can do it this way, then you're fine. Now I just keep adding 5 down, just to keep myself straight, right? And I want to have 6 of these. Good job on the room, Jeff. You do it. There you go, Jeff. All right. How are we doing so far? 1, 2, 3, 4, 5, 6. And don't freak out. This last number does not have to be the last data point. That would be just weird if it was. It would be kind of random. Right? So it just has, the last data point just has to have a class to go into. Right?
It doesn't always have to be done?
It can't always be the last data point. Do you understand what I'm saying? Because the oldest person could have been 44 or 46, or it doesn't have to be that. It just has to have a place to go. Right? You have to have a home. So how many were between 17 and 21? Let me do this for this side of the room, at least. My 4 little neglected side of the room. There you go. So it's always nice for the first one you could do this. You could do them for all of them too, but you just go down to the 21. So you just see what position I'm in. I'm in the 28th position, so it means there's 28 in that first class. In the next class, how many do you count? 11. Yeah, well, they were 11. Sounds about right. 27 to 31. 3. 32 to 36. 5. 37 to 41, that ever freaked everybody out? 0. I could have several classes that have nobody. Right? If I did heights of my kindergartners and heights of the teachers, there will be a large gap in the middle with nobody, right? You don't expect a lot of kindergartners to be up here and a lot of your teachers to be down there. All right, and then the last class had what? All right. And then how do you make relative frequency? Yeah, it's just percentage, right? So you'd say 28 students out of 48. So 28 divided by 48. You can round to 1 decimal place to make your percentage. What do you get? 58 point.
No. 0.58.
Sure. To make it into a percentage. I'm going to assume we can all do that. 0.3. Good. Cool. So 0.583. Move the decimal over a couple places, right? Because percent per hundred, twice for the hundreds. Sweet. All right, you're with me now. Good. And then just keep going. 11 divided by 48.
22.9.
22.9. 3 out of 48. 1/16. That'll be 6.66. 6 point who? 2.5? Even better. So we'll make it 6.3. And then 5 out of 48. 10.4. And then, of course, 0% there. And 1 out of 48. 2.1%. If you add all these up, they should be, close to 100. How are we doing? Is everybody decent? This is a really good time to ask if you have any problem spots or questions.
Well, I did it the other way.
The numbers should come out the same.
The percentages are different though.
So what percentage did you get in the first one?
52%.
Well, you did 28 divided by what?
No, well, I got 26 for that.
Oh. So even if you do it this way, you should still count 17, 18, 19, 20, 21.
Yeah.
Right?
Yeah.
So you should have ended up with 28 total ages that were in there. So even if you did it the book way, or if you did it the way I showed you with the inequality symbols, these numbers have to be the same. Everybody should have these numbers. I don't care which way you set this up. Is that cool? Everybody's decent? If they're not the same for you, they might not be the same for some more people. You can go ahead and speak up and not feel all bad. All right. Okay. So if I'm doing the book way, what do I have to do when I go to this? Where am I going to start? 16.5. And then I can just go up by 5 from there because my width is 5. Right? So if I just know the starting point is 16.5, now of course if you're doing it my way, you just go 17, 22, 27, But now we got to do 16.5. Somebody had a really good point. Sometimes you have a little heartbeat symbol there to show that there's a break, that there's nothing there. But if we just start somewhere, it's known that there was just nothing to show. We're not trying to hide anything. We're just going, let's go to the data. There's just nothing until 16 something, right? So 16.5. 21.5, 26.5, 31.5. All right, that should be plenty. All right, how we doing? What's the label for that? Okay, a little bit more. In years, right? Because I did ask you for your age in months. So I could have given you the months and make a histogram out of that. Oh, joy. You guys kind of with me? So units and a little bit of an explanation physically of what's going on. Don't just say classes, not good enough. On your homework, label your axes. So what am I going to label this? What kind of a histogram do I want you to make? So which column am I going to use from here? Yeah, it's crazy. Yeah, the middle column to make a frequency histogram. Right, so just pay attention to what kind of thing I ask for. So here I'm just wanting a frequency one. What kind of scale am I going to use? What do I want to get up to? About 30 sounds good. So maybe 5, I like it. Whoever said 5 over there. Don't go 2. Right, don't go 1. So 5, 10, 15, 20, 25, 30. I could have made a little bit more room than that, but too bad. How we doing? All right. Definitely, you don't have to go up to 100, right? You just have to cover up to as high as the highest one. So then we just draw in our rectangles. 28. It's about right there. 11, 3. This poor little dude doing. And 5, 0. What's up?
Just doing frequency.
Frequency histogram. So I'm using the frequencies. Yep. Very careful. Not a big deal. Just, just pay attention. Pay attention. So what's this going to be here? Sorry. Good. Freak. Did you just say freak? All right. That's really, really gross looking. But if yours looks at least like that, you're okay. This is another good reason why I would not want me as a student in my class. Yes.
Do we title the graph?
Titles I don't care too much about because the label's good for that. In general, if you're in a science class, you should title the damn thing, right?
Yeah.
As part of your report thing. Yeah. We're not doing a big old report. We're going to have a ton of these to do in the homework, so the label is good enough. Okay, so any questions on the whole procedure? Anywhere there? All right, cool. I like it. So, in general, I will allow you to have like a formula sheet, but one formula I'm not going to let you write down, I just got to know is the formula how to get class width. You should be able to remember that formula, right?
You probably asked or answered this question, I was going, but if we round it to a solid number for percentages, is that okay? Like I got 99% overall because I didn't have the 0.3, 0.7.
Oh yeah, if I don't say that's okay, but in general you want to go at least one place out. We're doing this by hand, so we can't really be that precise, right? But it just helps with rounding errors, It makes it a little more accurate in the end. Yeah.
What did you put for the x-axis? What were the numbers?
I did it the way the book would do it, so I had to do the boundaries. If you did it the way I did it, it would be 17, 22, so forth.
And those are ages and years? Is that what that says? Years?
Yes.
Okay.
Cool. I like it. Thankfully, I can still read that myself. I had a teacher that his writing was so bad, we'd say, "What'd you write up there?" And he'd say, "Does somebody remember what I wrote up there?" So I haven't done that yet. The minute I do that, I need to retire. I just need to leave the profession. I should go. Okay. All right, so here's what's going to happen. I said we might, and we definitely will. We're going to have a quiz on Wednesday on Chapter 1. So quiz Wednesday on Chapter 1. I check eraser. Oh, there's an eraser. Even higher. And then there'll be a quiz next Monday on 2.2 and 2.3. Yay. Okay, cool. All right.
So what about the ones that before next Monday? Do you have another piece?
Say again?
Like,
No, then we're getting into that Wednesday. I think it's going to be a review for the test. Because the Monday after that Monday is a holiday, if I remember correctly.
yeah.
And then we have the test that Wednesday. So the previous Wednesday is going to be a review for the test. So I'm never going to give you a quiz that I can't give back to you before the test day. Does that make sense?
So
Cool.
the test is on 1 and 2.
Yeah, so if you look at your homework sheet, the test, I think, is on the 18th. Is that right?
Yeah.
And the 16th is a holiday. It's Lincoln's Day or something, right? Washington, one of them. Lincoln just rolled over in Washington Day. Who cares? President's Day. So sorry to the country. So the previous Wednesday before that holiday is going to be review day. So on that Monday, good Lord, on this Monday I'm going to give you a practice test. And on that Wednesday I'll have the answer key. then you'll have so much time to study. You can look at it as so much time to forget everything, but you want to study. And when that following Wednesday will be our test. Okay, cool. All right, so let's finish up chapter 2. Yes, sir.
So, what decrease would
Like that. Yep. This is 2223. 22 is create a frequency table, a relative frequency, and section 23 is make the histogram.
It's going to be that just one person.
Yeah, oh yeah. Quizzes, I try to make them very quick, very to the point, very straightforward. Tests are not horrible, but they're not as like that.
On Wednesday, just
Yeah, on the quiz on Wednesday is just chapter 1, so it's just going to be the definitions. I'm going to ask you to identify something if it's cluster sampling or convenience sampling. I ask you, is it nominal ordinal interval ratio? Stuff like that. Yes?
so, do you want us to give like examples of what they are?
No. That's the most I would go in that direction. I never ask you to directly just give me the definition of something. If I say identify the sample, I must have given you some situation that I want you to actually reference. The 58 people that you picked, that's the sample. Does that make sense? Never say it's the collection from the population. No. Tell me physically, in the problem I set up, tell me what it is. Don't define it for me. I don't care about the definition. I care that you're able to identify these things. So you have to know the definition, but just be able to identify them, right? So I'll never ask you to define nominal level of data. I'll say this data, what type of, what level of data would jersey numbers be? What would that be? Numbers on jerseys? What level would that be? Nominal, because it's just the name of the player. There goes number 99. I don't know who the hell he is, but he's number 99. That's his name. He's running, right? All right, cool. Carrying a pancake. No, that's a football. Oh, I'm sorry. Okay, there is one thing there's always a few things in the homework that I might on purpose leave out discussing, because part of this whole class is that you have a book that you're supposed to read. And I always see if anybody asks me, so somebody did come to my office and ask this, so I'll bring it up myself. There's some stuff in the chapter 1 that's remarkably important, and it's about the difference between statistically significant and practically significant, right? So let me give you an example, one situation that shows you the difference between the two. You ready? Okay. So do you believe me? I could go out right now and randomly pick a bunch of students who were about to take the SAT. Is everybody with me? I'm going to go randomly pick a bunch of students who are planning on taking the SAT later this semester, right? And I could just happen to pick, if I randomly pick them, let me see how to set this up. If I randomly pick a bunch of students who are going to take the SAT, can you predict what their average score would be if we knew the average of the SAT? Let's say the average SAT test score, I don't even know nowadays, what was 1,050, whatever. That might be kind of high. I don't even know what the new scores are like. There's a whole damn new section since when I took it. Jeez. Well, let's just pretend that's right. Okay? I could have looked it up, but, that took a while. So I could go out and I could randomly select a bunch of students who are about to take the SAT. What's my best guess for what their average score is going to be? That, right? Because that's what we've seen with the SAT and the way it is now. You with me? All right. Is it possible that I could randomly select 400 students and their average would just happen to be 1,100? Of course it's possible. You with me? You with me? Is it likely that would happen? Now that's getting a little bit more detailed. So let me go a little bit more extreme. So in the chapter 1, whenever they talk about statistical significance versus practical, they have to be extreme. Extreme either... if I went and picked their average, what's the likelihood that their average score would be 1,060? You're like, well, that's pretty good because it's pretty close. But what's the likelihood that their average score would be 1,300? Do you think that would happen? I just go randomly pick students. And I just happen to randomly pick really smart ones. How likely is that? 400 of them. Is that likely?
Isn't it like 0 plus or something? Like it's like not technically not possible, but you can't say it's impossible.
0 plus means it's very small. It's less than 0.0005. Right? Okay. The book talks about 1% all the time. It always talks about 1 out of 1,000. If you've done the homework, you've seen that. So 1% is a decent cutoff. Around 1% or smaller it's so unlikely. But here's the thing. Statistical significance, the smaller the number is, the more significant it is. Because if I took a group of students, I took 400 totally random selected students who are going to take the SAT, and I give them a week-long workshop getting them ready for the SAT, like Kaplan does, right? Doesn't Kaplan do that? All right, forget it. Kaplan is the service that they do this. And then my students go, my 400 students go, they take the SAT, and they get an average of 1,300. What's more likely, that I just happen to randomly select students who are going to score that high anyway, or that my week-long workshop actually had an effect and made their score higher? What's more likely? The workshop had an effect. Because it's such a small, it's less than 1% chance that I would randomly select 400 students who would so greatly exceed the average score, right? An even better example would be, what's the probability I go out and select 400 people whose next baby would be 7 foot tall when they grow up? Not when they're born, thank God. That poor woman. Keep going. Beat you up, pal. That was a whole scene. You guys kind of with me? So very unlikely, right? I would say that the average height would be the average height of a random person in America, right? You with me? And then if I give them a drug, and then I wait, and they have babies, and later I see how tall they are when they're 18, and they actually are 7 foot tall, like almost all of them are at least 7 foot tall, then that's good evidence that my drug had an effect. There is a chance that I just happened to pick people that were going to have really tall freaking kids, right? There's a chance. But what's more likely is that my medication had an effect, because it's such a damn small chance. Do you guys see that? So now I haven't talked about practical significance yet. You ready? Statistical significance is the probability that what you saw happened by random chance is really small, which means whatever you did actually must have been why you saw that. So like the kid being really tall or the kid really doing well on the test, it must have been what you did, not you just happened to pick a bunch of really smart kids. How are we doing so far? Now what if I said it was statistically significant that the score goes to 1,060? And it's statistically significant. There's a less than 1% chance that would happen. 400 kids, it's actually probably true. 400 kids, the average goes up by 10. It's actually really hard for 400 kids, their average to go up by 10. It should be really close to the average of 1,050. And you're all thinking, hopefully you're all thinking correctly, which is, that's not much. So what if this week-long course, I say, yes, it will definitely increase your kids' scores. And in very small print, I put, by 10 points. And it costs like $200 a day to do this. And the kids are in there for 10 hours a day. And I don't let them have breaks. So is it practically significant? Would it actually change your behavior? Would you put your kid in that workshop? Yes, because you want some time alone home. But it costs money, so maybe not. So is it practically significant? No. If there was a weight loss program, and they said, yes, it's been proven, statistically significant weight loss. And then they say the average weight loss was 0.5 pounds. And you have to be on this for 6 months, and you can only drink water. Don't get too excited. There's something wrong with the program. I don't think that would work. I did not just endorse anything. Don't give me trouble anyway. I totally lost my train of thought. It's too bad for me. What is in here? What was I talking about? Oh yeah, thank you. So yes, it's statistically significant. It's very unlikely that that weight loss was just because you happened to choose people that were going to lose that much weight. You with me? That's what statistical significance is all about. How does it compare to what would normally randomly happen? Is it weird? Yes, that was really weird. For the group of 300 people you had to lose, on average, half a pound. That normally wouldn't happen randomly. But is it practically significant? No, I'm not going to go on this crazy-ass diet thing where I have to mush everything up and drink it through a straw or something, and I have to whatever. You guys kind of with me? For 6 months, and it costs $1,800 or whatever. You guys kind of with me? Do you see the difference there? Statistical significance means statistics says, oh yes, whatever you just did actually made a difference. Practical significance is that difference enough to make me actually change my behaviors, to do the workshop or whatever. All right, maybe. That's hugely important for later in the semester, right? And later in the semester, we're actually going to knock down some of this. We're going to make it a lot more specific as to where, what would be weird. 1,060, 1,100, what would be strange, right? Okay, maybe. Okay. All right. So anything else from chapter 1 before I move on? I definitely want to knock chapter 2 out. We have one section left in chapter 2, section 2.4. I'll make sure I didn't skip anybody. No, good. And I want to show you something. Here's a different kind of graph. This is from the data you guys gave me. So this is always really neat. I'm always worried that too many people are going to know my intention with this question. Oh, that was it, Jeff. Pay attention. All right. Whoa. Oh, dude. There you go. Here's all the data you guys gave me. Yeah. Now look at this. This is kind of neat. This is the results of my asking you to pick a random number. I enjoy the person who said 17. I like that. Because the question was a random number between 1 and 10. Somebody said, I don't like your question. Answer my own question. Or you might have mistyped. I don't know. So I just put 17 up there because I don't know what you intended. But what do you notice? It's kind of weird.
7.
I mean, if it truly is a random number that you are selecting, what should the picture have looked like? It should have been pretty straight across, maybe little bumps, because we're a relatively smaller group. But if I had a bigger, it should be straight across. So what's really interesting here is this is a very well-known, documented psychological aspect of us. Yes? You're thinking about why the bell curve looks the way it does. And that's just because normally a large group of people are going to perform in the middle. Sort of like the income distribution. A large group of people are going to make in the middle. Very few are going to be billionaires.
Yeah, but
Right?
the middle is like pretty low. It's just like 7, 8, and 9.
The middle is pretty damn high.
Yeah.
Yeah. But this is not that. I really want you to understand. There should be no reason for this to be bell curve. It's not really. This is something totally separate. If I asked you to pick a number from 1 to 20, 17 would have been the highest. 7 would have been the second highest. And from there. I'm getting there. The quick answer is we don't know. But every semester I've done this since 1998. Yes, I've been teaching since 98. I was 26. I was really. Every semester I've done this, it's always come out something like that. One semester, 8 was almost there with 7. And I think that was a year there was, it was 08. And there was that 888, and everybody's getting married then because that's, Chinese have the 8's good luck, right? 888, I think. And it's infinity, yeah. But every other time, 7 has been well above. And it's just, when I say pick a random number, people are like, for some reason, we immediately discount even numbers for the most part. Although here, 4, what is it, 2, 6, and 8 are kind of like the next highest, right? But if you ever watch Mythbusters, for example, notice how nobody picked 1. If you ever watch Mythbusters, the whole thing about the bathroom, when you go in the bathroom, nobody picks the first stall because everybody thinks everybody picks the first stall. So your brain is like, what number would nobody else pick? And of course you end up picking the number everybody else does because everybody else is thinking the exact same thing. Now, not everybody picks 7, of course, thank God, or else that would really freak me the hell out. Somebody's going to happen to pick something else. But if you give it any thought, your brain says, I don't think anybody's going to pick 7, because it's a weird little number. It's odd. They don't really know exactly why. But 7, 17, 27, 37. Whenever I make up a number, I almost always pick 37. It's weird. It's just something weird about our brains. So it's really neat. So it shows you that we could never be random number generators because there's a bias built in. All right, how are we doing so far? That's neat. But the other thing to notice, is that a histogram?
Kind of. No.
Why is it not a histogram?
No.
It's not meant to be a histogram. So this is actually called a bar graph. For one thing, it's not made from classes, right? These are more labels, not really true numbers, because my scale isn't consistent, is it? Because it goes to 17 out of nowhere. You kind of with me? So a bar graph can have gaps between the bars. In fact, you want them to have gaps because you're not trying to represent a scale. And normally it's for qualitative data. Like if I went out to the parking lot and just counted how many people have Hyundais, how many have Fords, how many have Chevys, how many have BMWs, right? How many have bikes? You with me? And I just put them up there, BMW, and then the height was how many had that. That would be a true bar graph. It's normally for qualitative data. How are we doing so far?
For quality.
Yeah, bar graphs are normally for qualitative data. This isn't really qualitative. It really is numbers, but I didn't make classes with them. I have some off-scale kind of stuff up there, so it doesn't really follow the number scale like it's supposed to. All right, so that's a bar graph. They can have the gaps. Here's something else I did, because I just love messing with numbers for some reason. Let me see if I can find it. So that's that. Oh yeah, that's the 2%. Oh wait, that was the histogram I made before I added 2 more people that did the survey. Is that what it ended up looking like? Yeah, that's pretty much what it looked like, right? The histogram we did? Alright, let me find the other stuff here. Here it is. Alright, so here's something interesting. I took everybody's height. These are all the heights you guys gave me. And then your father's height and your mom's height. And then I averaged your father and mother's height. And then what I did was I made what's called a scatterplot. So if they ask you to make a scatterplot, this is all it is. It's graphing x, y points. You with me? But in this case, the x-axis is the average height of your mom and dad. And the y-axis is you guys' height that filled out the survey. So I just made a scatter plot. A scatter plot, one reason we do it is to see if there's any trends in the data. Do you guys notice any trend? What do I mean by trend? Are they trending up? Is there no trend? Are they trending down? Yeah, if you drew a line to average those points out, you would draw it kind of like that, right? In fact, if we had enough computer lab space, we'd probably teach this class on Excel. Okay, I'm done with you. Go ahead. So here's the equation of the line that best fits that data. So I can make a prediction. I can predict how tall somebody would be. Somebody just had a baby. If I take the mom's height and the dad's height and average them together, I can plug that into that formula and I can kind of predict. How good would my prediction be? Look at the points. Are they very close to the line? My prediction would probably not be very good. But there is a trend, and you expect that. What's the best predictor for how tall your kid's going to be is how tall you two are. And then what's the next best predictor is how tall your parents, the kid's grandparents are, right? Because you never know when that height gene is going to come in out of nowhere and go, where the hell did you come from? Yeah. And that's, of course, explains all the extreme variation. This is only going back one generation, so there's so many other variables that go into this, but even just one generation back, you can see a decent trend, and a very easily observable trend. Let me say it like that. Cool. How are we doing? Some of you guys are bored. You're looking at the cell phones. That's all right. I can't really compete with that. So much good shit on there. Okay. All right. Good. So that's 2 things in this section, 2.4. You're going to have to make your own scatter plot. I don't think I made you make bar graphs. You should have seen enough bar graphs in your life to know how they look and how to make them. It's just like making a histogram just with names instead of numbers at the bottom. But you will also have to do something called a dot plot. Shoot, I just missed all that. If you guys could help remind me. If you're at home, that's what I was talking about. All right. It's my bad. If you guys forget, then it's my responsibility. But if you guys could help me, I would so much appreciate that. All right. So let me make up some data to look at a dot plot. A dot plot. And actually, I'm just kind of make up some. It's already going to be in order just to make this easier. Just keep going. Dot plots are remarkably simple. And they're really, really nice because they kind of give us the same information the histogram would. Dot plots work best with repetitive data that repeats. And you'll see why here in a second. So if I do a dot plot of this, 18, 19, 1x, 1 and y, 22. You'll just put a dot over every data point that shows up, every time it does show up. So I see 18, 1, 2, 3, 4 times. 1, 2, 3, 4. 19 I see twice. 20 I see twice. 21 I see 3 times. And 22 I see once. I mean, that's how you make it, right? Very simple, remarkably simple. If your data look like, what do you got, Jeff? 3.2, 3.4, 3.7, then you make your scale better. You make your scale 3.0, 3.2, 3.4, something like that. You with me? So you can find the data easily. If your dot plot, does this look normal? Of course, in statistics, we all know what normal means, right? Some of you guys are like not used to the word normal, and you're like, I don't know if that looks normal. But normal, of course, is what shape? Bell curve. All right, so the word normal in statistics means a bell curve, right? So this totally does not look normal. But you certainly could do a dot plot somewhere in the homework. That would be roughly normal. Go ahead, bud. Is that perfectly normal? Is that perfectly normal? Hell no. Is it loosely normal? It's even actually stronger than that. I'd say this is pretty damn normal. Even though it has like a couple of things that are not really what they're supposed to be, that's really pretty damn normal, right? Especially because it's a very small sample. It looks like it's really damn normal. So a lot of your homework in this section, you're going to have to create a picture, and then it's going to say, tell me something you notice about the picture. Tell me something about the picture. One thing you could say is if it looks normal or not. It's a really good thing to say. Doesn't look normal, it looks normal. Or things seem to be clustering around younger ages. If we had a lot of, people seem to be younger. It's not normal, but it seems to be skewed towards the young end, right? Like I'd expect in an intro stats class in college. Okay, cool. Yeah, section 2.4, it's not too evil, but just let me know if you get something that sounds weird. Somebody's like, I'll let you know if something does not sound weird, Jeff. That'll be quick, that'll be easier. So the last thing I want to show you from 2.4, there's a lot of things in 2.4 we're not going to worry about. Time series, Pareto charts, frequency polygons, right? I didn't assign any problems to those because they're really not very often used. Time series are used, but you pretty much know how they look. Bottom of page 62, there's a time series. You know, just that the scale is going to be by years, and you can track like your income or Dow Jones averages, what they have on there. We all know what that looks like. I'm not too concerned. But the dot plot we're not used to. The scatter plot, I want to make sure you realize it's just exactly what you do in algebra, plotting XY points. And then there's one more, and the book calls it stem plot. It's actually called the stem and leaf plot. Sure it is, Jeff. Yes. So let me make up some more data. there's some data. So here's how the stem and leaf plot works. Your stems are going to be related to the first part of your number. And the leaves are going to be related to the next digit or digits. So, the stems here would be, obviously for these, what's the first number? 1. So what am I going to put for this guy? 0. I like it. So 0, 1. You don't skip anybody just because there's nobody there. This is just going to be blank, right? How are we doing so far? Nothing any incredible. If it was 70, 100, 110, I could have put 7, 1, 0, 1, 1 for the first couple. It depends on how much they change. The data changes. So I'll show you a couple more examples in a second. But here I put 7. Here I would put. What else?
1, 2.
So you have to represent repeats. And what this is really doing is it's a very, very quick way to get a really quick, rough histogram, believe it or not. You'll see here in a minute. So you don't want to, just because it's repeated, don't just put it once. You want to represent how many data points there are. You don't want to miss anybody. In 2, it's going to be empty. In 3, it's going to have
1, 4, 5.
in 4, and in 5.
9.
So if you look like this, that looks like a histogram. Do you see that? And it's also, if this wasn't in order, it's also kind of a quick way, if you had to do it by hand, to sort your data. Kind of like breaking it down into these and then sort them within there. Does that kind of make sense? Of course, we have our calculator, thank God, it paid enough money for it, or somebody did. Should be able to do that for us, right? So is that decent? Now, what's wrong with this so far is this data could represent this. That could be what that represents. You guys kind of with me here? So I have to have a key. That's not what I mean. I have to say something like this. 0, 7 means 7. That's my key. So if I ask you to make a stem and leaf plot and you don't have a key, I'm going to take points off. Because I don't know what you mean.
Do you have to do it for each number or just
Now, I hope you realize, I don't want to pick on you, but if you did that, it would sort of take the whole thing, the whole purpose away, right? I only need one key, and then I could read the rest of it. I know what it all means. So they told me 0.7 means 0.7, then 3.1 means 3.1. See, it sets up the whole idea for the whole thing. Cool. If you had to do each one, I'm like, well, just list the data for me. Okay. How we doing so far? All right. Good? Good. I like it. So right now, what's always weird to me, I want to make sure everybody understands this, but it isn't that hard. But you're all like, when is it going to get hard? I can tell you're all like, at some point, it's going to get really hard. And that's coming. I just want you to know. Okay. The other part of section 2.4, yeah.
About the table. Like the zeros and 1, 1.
What about it? What?
We didn't really get it.
Let's do another one. Can you see, what is this 3.1? What is that? Can you find it in the data? What does 3.1 represent?
31.
145.
41, 34, 35. So this is why we call it stem, leaf.
Okay.
The stems are the first part of the number and the leaves are coming off of that. So let me do another data set. What if I had this here? Got it roughly in order. All right, that's plenty. So what do you think my stems should look like? If my stem was 1, then I'm going to end up with just one big list. Right, that's not really going to serve much of a purpose. Yeah, so I could do like this: 12, 13, And don't skip somebody just because they're not there. It's got to be like a consistent scale here, right? But see, the key is what ties it all together. So do you see what I mean about how much they vary? If it would have been all 1.21, 1.22, 1.27, 1.24, all 1.2s, then I would have maybe even tried to break it down even more, which you actually can do. You could break it down in like the 1.20 up to 1.24, and then 1.25 up to 1.29. You can kind of break it down even further. If you just have one big row, what the hell's the point? And I know some of you guys are like, what the hell's the point of the first one? But it's a very quick way to organize your data, and it's a very quick way. This is much quicker than actually making a whole histogram, right? That took us a long time. Some of you guys are going to be like, oh, let me just do that. Well, it's because it's not. It's just a real quick, rough sketch. So if I do this, what would I put here?
7, 8.
And I could be a little smart, and I could put 7, 9, put it in order, right?
0, 1, 5, 5, 8.
5, 5, 5, 8. 9, skip 1, 6, right?
0.
And 0. So if it looked like that, I would say that's really roughly normal. This is barely normal. You kind of with me? And then your key would be what? Key 12.7 means 1.27. That's where you tie it all together. That's why you have so much flexibility here to capture what really is changing, because then your key can tie it all together. Yes, sir?
How do you get the key?
Oh, you pick it. I mean, what did we mean by 12.7? What did we mean by that? What did we mean by this? We meant 1.27. That's where it came from. That's exactly how I write it. So you can pick any one of these as the representative element, right? So normally I just pick the first one. But please, dear God, don't do for any more. You just need one. It's like a scale on a map. I just need one scale. I don't need you to put it everywhere, right? Okay, cool. I like it. All right. This is relatively easy stuff, but it's new for most of us. We want to make sure we're all on the same page before we get to the freaky stuff. How are we doing over there? Is that cool?
Yeah.
Makes sense? Okay. So the last part of this section is all about how can you mislead people. It's like that show I've never watched. I don't think I ever will, but the class How to Commit Murder. What is that class? The show. Huh? How to Get Away with Murder, right? All right. I'm about to show you how to mislead people with statistics so that you are smarter about when you see things and you're able to interpret it better. Because I've seen this shit in newspapers. I've seen it on freaking news shows. And you wonder, are they just stupid and don't know how to put this together? Because if they're presenting it, they better know how to put it together. Or are they smart enough and they think all of us are stupid and they're just trying to pull one over on us, right? Okay. So, here's something. Everybody got this here? Let's see if the book still has this. Well, that's a good one. I want to make it a bad one. All right, here we go. Let's say in the next 2 weeks. What is it now? It's been a couple weeks since I gassed my car. But it was like 2:30 then. Is it still 2:30 or something?
I seen it at 2:19.
Of course, I look for my Arco, right? I don't know about you guys. Because I love the Shell down the street that's still like $4 or something crazy. People are still going there. Lord, man. Let me see if I can do. Let's see. Let's make it even worse. No, it's not sure. You're writing this down. Let's say right now it's here. So we'll say February 1st. Or what is it? 2nd? Groundhog Day. Still saw a shadow. What do we care about that in San Diego? Not much. All we care about is El Nino, please, form, water, good. And then let's say 2 weeks from now. So you do the math, Jeff. You can do it. There you go. And let's say it goes here. And we're like, holy shit, look at that. I mean, that's crazy. This is horrible. What's going on here? rah, rah, rah. And normally the one I do is something like men and women's pay scales, right? But I try to stay away from overly controversial things. Obviously there is a difference. But what sucks, the worst thing in the world is when you really believe in something and then somebody does something like this, and this is kind of a stupid thing to do it for, but just anything like this. And you're like, the minute you misrepresent something, your whole case kind of loses a huge chunk of respectability, right? Or people don't buy into it as much. And you're like, oh, shit, you didn't have to do that, because something like men's versus women's pay scale, there is a difference. You don't have to like overstate it. You don't, just stick to the facts, or else people are going to be like, you guys are all crazy. Look at that shit you did. Who cares about you? You guys kind of with me here? So you never want to do this on purpose. What's wrong, though? What could possibly be wrong with the way I've represented this? Is there anything wrong with the way I represent? I mean, look at that huge spike in gas prices. Look at that. More than doubled from there to there. Did it? It didn't double. That's 220 to 240. But what does it look like? It looks like it almost doubled, right? So what's wrong with this? Yeah, what about the scale?
It's like the length from like the 2.10 to where it starts is like the same as...
Exactly. So how much is this? Looks like it's 210. But then my scale is 10. So it's all because this thing does not start at 0. Sweet. You with me? Especially when we have something like this, because our eyes always look at it exactly like I said. Oh, that's twice as tall as that. Ooh, but then the height doesn't mean shit because the way the scale is. Now, if I change it, so part of the section 2.4, they're going to give you a bogus picture, and you're going to have to change it. They're going to say, re-represent this so that it is honest. So one thing it does is the scale is supposed to start at 0. So I redid this at 0. And now I'm at 220 and 240, so I want to go up to, let's say it doesn't really matter, 250. So what kind of scale should I use? By how much? Yeah, maybe 25. So let's see, 25, 50, 75, 100, 125, 150. Oh shit. Maybe we'll do 50. 50 cents, $1, $1.50, $2. Now I'm pretty close. I can live with that. 250. All right. Okay, cool. And then you put 220 is going to be about, here's 225 roughly, right? So 220 is about right there. And then 240 is about right there. Now that is an honest representation, right? Still a change, still a jump. Right, and 20 cents is actually a decent jump, but you've lost all, whatever your argument is, you've lost all respectability when you do something like this, right? And it really sucks when you actually have a point. And then people that you're arguing against just point to this and say, "Now shut up, sit down." Because you can't do shit, you can't. That happens all the time here, trust me. We have, in the Senate, we have these discussions and somebody does something, and I'm like, don't say that, oh shit. And because I'm like, yes, I believe in this, but you didn't have to go and exaggerate something. That was stupid. Nobody's going to believe in what we're saying now. Shit. And I can't blame the other side, really, but anyway. All right. So, we all know about statistics, and if you're not careful, or if somebody else is way too good with it, then this kind of stuff could happen. Okay, so there's some other situations in section 2.4, but that's the main idea. One of the first part of 2.4 is creating your own good graphs, stem and leaf plots, dot plots, so forth. And the other part is identifying what's wrong with some given graph and kind of redoing it sometimes. All right? Good. All right. How are we doing so far? This is good because I kind of wanted to sneak into chapter 3 a little bit today and then let us out early. It looks like I might be able to do both of those if you're all being honest with how you feel. Let chapter 2 be relatively easy. Let it be easy. Because after we get, and I don't want to scare you guys, but obviously it's going to get a little bit more complicated. A little bit. So I want to talk about, and actually let me pull up some articles from the internets. Let me go to the Googlies. So if I talk about home prices in San Diego, how are they normally discussed? There you go, perfect. Zillow is good for this. So what's a word in that? Okay, stop. All right. First off, some of you are looking at it like, this is exactly why once I get educated, I'm moving out of here. Oh, thank you. So what's a word in that thing that seems to be kind of important? Happens very, very, very early in that little write-up there. Median. The median home value. They didn't say the average, right? And in fact, the average is a bad kind of word to use because it could mean several things. In statistics, when we say average, we know what we mean. If I want to take the average of 5 numbers, how would I do that? Add them all up? Divide by 5. When you say that, you really mean the mean. So in statistics, we call that average the mean because the word average actually means several different things. So in this class, when I say the mean, that's what you normally consider as the average. The median is actually another kind of average. But why do you think we can't use the real mean for home prices? Why would that be throw people off who want to move here or something, right? Yeah. Or let's take something a little smaller. If I was going to start working at a company and I asked them what's the average or the mean in salary made, and they tell me this big number, and I'm like, oh, cool. So let's say there's 5 people that work here. This is why you got to hire a camera person. YouTube's going to offer to make it not shaky, but oh well. We notice it's shaky. Too bad. So let's say you go to this company and the salaries in the thousands of dollars look like this. Thousands of dollars. So 40, 48, 49, 57, 250. Who's this? Big boss, right? Big boss man or woman, right? Anyway, these 4 people. Little peons, right? Yeah. And then we got this new dude that wants to start working there, but he's going around the different places. He's asking, what can I expect? So the average, the mean is what we call it now. The mean income would be misleading. How would it be misleading? Exactly. So going back to house prices, if you go out to La Jolla, you do that. I do that just to look at the houses and go, ooh, I'll never live there. Right? And they're neat to look at. And I'm like, I don't know if I'd want to live there. But that might be low-hanging fruit. Too bad. Same thing with the income. If I take the average for me real quick. This is exactly what we were talking about earlier. We got 5 numbers up there. Take the average. What do you get?
88.8.
88.8? So $88,800. That's what I'd tell the guy if he said, what's the average? I'd say $88,800. Really? Oh, okay, well. When really that's not representative. That's not what he should expect. So the average, we already know what that is. The mean, what we just did here, let me show you the symbol and show you, this is our first statistical equation. So this is our first introduction to some of the Greek symbols that are used in the formulas for statistics. You do not have to learn Greek. Right. This might be where the saying, it's all Greek to me, came from. But the mean, in fact, we'll be very specific. We'll say the sample mean. This is just a sample. It's a sample mean. You use the symbol X with a bar over it. Okay. And so how do I find it? How do I say it in English? We said it in English earlier. You would add them all up and divide by how many there are, the number of them, right? So what letter do you think represents all the different values? What letter do we use in algebra to represent a whole bunch of possible values? X. So this list would be the list of X's, the list of values, the list of variable values. You guys semi with me? So in English, this is add them all up, divided by the number of data points. How are we doing there? Is that cool? That's in English, right? That's not very useful. We want Mathish. So in Mathish, add them. What's the more official word for adding something up? I pretty much just give it away. Sum, right? So sum, and we use the Greek letter S. And you normally see this in fraternity, sorority organizations. Sigma, 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 right? It's sigma. Capital sigma. We'll see lowercase sigma later in the semester. It means something totally different, right? So capital sigma, math people being very creative said, how do you represent sum? The letter S. We want it to look more official. Greek. Super Bowl. Here's interesting. Next year, I'm very curious. What Super Bowl was this?
49.
Yes, but how do they always show it? XLIX. Yeah. Right? And it's really funny that Google Trends, the people look up Roman numerals around the time of the Super Bowl. What are Roman numerals? Next year, it would be L, and they're not going to like that. All the XLIX and all that crap, they have it in, like, they have the graphics, it's all in brick, and it comes falling in stone, and it falls down, boom, Super Bowl. But when it's L, Super Bowl L. They're not going to like that. So I'm not really sure what they're going to do. You guys semi with me? They'll probably say XXXXX, and they'll just break all the rules of Roman numerals. Right? X is, and then that would, who knows what that would possibly mean. So add all up. So sum all the values, add these up, and what letter do you think we use for the number of data points? N. That's how to, yeah. So there's our first little formula. It's kind of nice that we start with this because we all know how to do average already. So you don't actually have to remember that formula. We know how to do it. This just kind of introduces us to what these symbols represent. So the letter N always means the number of things we're looking at. Sigma always means, uppercase sigma always means add them up. So how do you think I do this? If sum of x, what was the sum of x again? What did you get when you added all these up? I'm sorry?
444.
444? Neato. That's cool. So how do you think you do this? Let me do this versus this. Is there a difference between these two? Hell yes. It's that good old thing from algebra. Remember this evilness? This is 4 with a negative in front, so it's negative 4. And that's when people come up and say, my calculator's broken. No, you're squaring 2 and then putting a negative on it, so that's negative 4. If you want to square negative 2, you got to do this. Then, of course, that would be negative 2 is 4. So this says square that. So I would square 444. Are you with me? That's what I would do right here. I'd just replace that with 444, square it, get whatever the hell that is. How would I get this? What does it say? It says sum up all the squares of the value. So what would I have to do first? Make a list of x squares, right? 1600, and then I don't know, whatever. You guys semi with me? Now we're not going to have to worry about that until section 3.3, which is the next section. We'll start doing stuff that involves x and x squared and all that kind of stuff. And even more than that, we'll have some other stuff. But as long as you're up on this, this is a sample mean. And of course, where do we take a sample from? Population. So the population mean looks like this. It has a symbol. Now, of course, the population, sort of like the Super Bowl, we want to make it more, So we use a Greek symbol for it. The little sample mean gets our symbol. It's bar. Population mean gets mu. Right? It's like a U. That sounded horrible. Like mu. So, a cow with some issues. So it looks like a U with an extra leg. People just make it an M, but it's not an M. Do you see that? It's not an M, but if you make it a little M, I'm not going to, what can I say, really? But it's a little U with an extra leg on it, and you pronounce it mu, so it sounds like a French cow normally. And it's got the same formula. The book uses a big-ass N, but who cares? N is always the number of things you're looking at. So it uses a big-ass N because it's the whole population. Ooh. And because I said this, and then I'm going to let us go. I said I was going to let you go early. I'm going to stick to it. The mean is no good on stuff like home prices and incomes because the large values will skew it. Right? It won't be really representative. How do I find the median then? The median It's got a symbol like this. Oh, you could do better. It's X tilde. And define the median is just the number that's in the middle when you put them in order. So when there's 5 things, there's obviously a middle. It's right there. When there's 4 things, where's the middle? Average of the 2 in the middle. But it only makes sense if they're in order. Otherwise, it could be whatever the hell you want it to be. So all these in order? Yes. So what's the median income? Yeah, so if you tell the guy 49,000, that's being much more honest. It's much more representative of what he could make. It's not skewed. The median doesn't even give a shit what that is. All it knows is it's bigger than 49. So it's more of a truly middle in terms of the number of numbers, whereas the average, the mean, is the middle in terms of the values of the numbers. I think that's plenty. So that's part of section 3.2. So we have gotten into there. All right. So there's still a little bit more in 3.2. We haven't finished it yet. But that's plenty for today. So don't forget, several quizzes in your future.